So number 12, I want to prove that these lines are parallel. In order to prove those lines are parallel, either I need to show alternate interior angles are congruent, same side interior are supplementary, or corresponding angles are congruent. So here's my goal. My goal is to show that this angle here, I'll highlight it, I'll make a big mark there, is congruent to this angle here. Those are corresponding angles. The whole thing is, not chunks of it, but the entire thing is a corresponding angle. You have to forget about the other lines. Remember that. So if I would draw a transversal, we'd have to realize that this entire thing and this entire thing are the corresponding angles. So the important part about that is for them to be congruent, we have to be able to set up an equation that looks like 10x plus 17 equals both that 87 and that 5x. So I then have to say it equals 87 plus 5x because we can add angles because we have that angle addition postulate. So now I have this entire angle here is equal to that entire angle there. Then I just have to solve for x. Is that pretty good on that? Those are the tough ones because we don't see we have to have the entire angle. Yeah, go ahead.
Letter H on like the big chart thing.
This chart thingy?
Yes.
So we're looking at letter H.
I put it was, you could do it on the answer sheet, so you could.
Okay, let's look at it. So it's 9 and 24, right?
Yes.
So let me just mark 9 and 24. 9 is here. 24 is here. I said the big thing that you need to be able to do is you need to be able to highlight what lines form the angles. So if I look at this bottom left one, it would be these lines that I'm highlighting in green. And for the other one, I'll highlight that in purple. Now, Patrick, let's look up here. Do we have one transversal and two lines?
No, there's two transversals.
There's two transversals and so there's multiple things, so we can't do anything with this. Particularly from the fact that we don't have parallel lines. So if you don't have parallel lines, you can't say like this angle is congruent to 22, and that goes to 17 because you don't have parallel lines.
If they were congruent, though, would you be able to?
If we could say that all these were parallel, we could work our ways to say they're congruent. But we don't know if they're congruent, or all we know is they're congruent. We don't know if we have parallel lines. So be careful about this. You can't use corresponding angles or alternate interior angles until you prove it's parallel. Okay? Yeah.
I was confused on number 13 because it was just difficult. Like I said, alternate interior, but I couldn't really find.
Okay.
Alternate
I gotcha. These are tougher ones. These are those tough ones. Oh, yeah, Flynn, did you have a question on what I just covered? A different problem?
The first one would be parallel. It's fast. So
No, you're good. I just want to make sure that I'll get yours.
For it to be parallel, it has to have one transversal and two lines.
Yeah. For me to even think it's a parallel line, it first has to have one transversal and lines. Then I have to look to prove that we have alternate interior corresponding or same side. So if I know these are congruent, that's not going to help me. Yeah?
Is that why you can't do 12 and 15 because it's only two lines?
12 and 15, those are just vertical angles. Yeah, so it creates two lines. So if I look at 12 and 15, I can even just say those are vertical angles. We don't have a vertical angle converse that says if you have vertical angles, then they're congruent. And like you said, if I'd highlight these, that just makes a line and another line. How can they be parallel? They can't. All right, now let's get to Tito's question. Tito, you were looking at number 13. 13, let me highlight the parallel lines first, or the potential parallel lines. Remember, they're not parallel yet. And then I'll kind of look at a transversal. I'm going to look at this transversal, Tito. That one right there. Okay, now if that's a transversal, I'm just going to highlight what I picture are my alternate interior angles. All of this and all of that would be alternate interior angles.
Okay, but how would you find out like the other half
Of 16x?
Yeah.
Because we need 16x plus this little section right here, right?
Right. So what is like
So now this is actually using two transversals, so I'm going to highlight a different transversal. If I look at 48 and right here, these are alternate interior angles. They're not corresponding, they're alternate interior. Let me erase. Remember, once you highlight stuff, everything else is gone. So if I erase this line, I erase this line. Those are definitely on the interior between the two purples, and they're on opposite sides of that line. So if I bring everything back, that means that this 48 is congruent to this, so that's 48 degrees. And now we can go ahead and I'll draw this transversal and say I need this entire angle and this entire angle being congruent. And so I would then write 28x equals 16x plus 48. And then solve that. Does that make sense? So you have to use two different transversals there. You have to understand you have something missing. There must be some way to get that missing item.
Okay.
But that's exactly my thought process on that one. I first would have drawn that first transversal and go, I'm missing that point. How do I get that? Okay, there's more transversals.
Okay.
There's more transversals. All right. Other questions on the homework? I got them all up here, so you might as well ask. Yeah, Michael.
Is it okay if I ask something about the notes? Like, the 3.4 notes?
Sure. What's up?
I still don't really understand the fourth example. When you're proving the lines are parallel.
The one that says none?
Yeah, I don't understand why it's not.
Well, what's 105 and 105? What kind of angles are those?
They're vertical angles.
They're vertical angles. Do we have a vertical angle converse that says if you have vertical angles, then you have parallel lines? So how could you prove it, I guess?
I just, like,
Let's look at it.
what if you did the corresponding angles thing?
Ooh.
Alternate interior.
Okay. Now remember to use a corresponding angle theorem. So you want to say maybe like 105, this is congruent to that maybe or something?
Well, I like the one on the bottom, just move it up to...
Right there?
Yeah, and then...
Okay, let's stop there. Let's stop there. In order to do that, so if you look at the theorem, it says if the lines are parallel, corresponding angles are congruent. Are these lines parallel? We don't know, so I can't do that. The only time I can say 105, the only time I have congruent, I agree these are corresponding angles, but these have to be parallel to use the theorem that says they're then congruent. Until they're parallel, you can't say anything about them being congruent. That was the whole point of that whole section, is showing that you can prove parallel lines. So if I look at number 2, notice how I gave you congruent corresponding angles. So now I can say these two lines are parallel. So I can say L is parallel to M because of the, maybe I should put this after. So if I was doing a proof, it would look like corresponding angle converse, and that would prove that L is parallel to M. Now I could put the parallel lines on there. Now everything else is fair game. You have to understand that the theorems and the postulates are predicated on them being parallel first. The converses show that they're parallel. Until we show they're parallel, we can't use the theorems or the postulates. Is that a little clearer? You just have to delineate what they're asking. Are they asking you to prove they're parallel? If they are, you can only use the converses. If they give you parallel lines, you can use the theorems and the postulates. That's the way I divide it up. Okay, other questions? Okay, today we're going to do some proofs. We're probably not going to get through all of them. We're a bit delayed, just the way the day worked out. But we're going to write some proofs proving lines are parallel. So Michael, this goes back to your question. So if you look at the first thing, it says angle 4 and angle 7 are supplementary. I need to prove that J is parallel to K. To prove they're parallel, I have to use converses. So I know right now I must use converses to prove that those two things are congruent. So what I have to realize is I'm at 4. Let's highlight 4. I'm also at 7. We have 3 converses that prove lines are parallel. We have alternate interior angle converse that says if your alternate interior angles are congruent, then you have parallel lines. We have our corresponding angle postulate converse that says if corresponding angles are congruent, then the lines are parallel. And our final one is same side interior angle converse that says if same side interior angles are supplementary, then you have parallel lines. Are 4 and 7 same side interior angles corresponding or no? So it's going to be our job to force them to be. It's our job to somehow make these either same side interior, turn them into alternate interior, or turn them into corresponding angles. And there are multiple ways to do this proof. So before we get started, I just want to put the given down, because you don't want to be that person that loses points because you didn't write the given down. And make sure you write numbers. So I have step 1 is angle 4, and angle 7 are sup. And that's
We're having like the
Give it.
converse on our test, correct?
yes. Yes. You just took the quiz, so the converse was not on there. All right. What's some ways we can get 4 to 7? I'm going to write all of them down, and then we're going to pick one way because I have to go a specific way because I didn't give us enough steps to go through all the ways, unfortunately. But I saw your hand first.
angle 7 is corresponding to angle 3.
7 is corresponding to 3. We can't use that yet, though, because we only could use that if they're parallel. So anything that depends on them being parallel, we cannot use. Yeah.
Angle 7 and angle 5 are vertical angles.
Do you see that? That's not dependent on them being parallel. So one step we could do, I'm going to highlight it in green. You don't have to write it down yet, but this is a great way to do this. This is probably how I would do this if I didn't give us such. I'm going to show us a different way to do this. But we could say 7 is congruent to 5. We could use substitution to put 5 in for 7, and also we have angle 4 and angle 5 are supplementary, so we could prove it that way. So that's a great way you could do that. I'm going to pick a different way, but that's a great way. Tito, did you have another way?
I was just going to say what Everett said.
Oh, okay. Yeah, that's probably the most clear one, right? Move 7 to 5. Substitute 5 in for 7. And now you have 4 and 5 being supplementary and they're same side. Yes?
7 and 8 are supplementary.
I could say 7 and 8 in supplementary. That's the way I'm going to go. So, now, play along with me real quick. If I did the vertical angle method, I would have to change everything to measures because we'd have to use substitution. So if I was going to go 7 equals 5, I'd first have to say measure of angle 4 plus measure of angle 7 equals 180 by using the definition of supplementary. We would then have to use vertical angles. Then we have to say they're congruent, means they're equal by definition of congruent. Then we can use subs. So it's a few more steps. It's probably the way I would go. But I really like the idea of 7 and 8 are supplementary. So that's what I'm going to go to next. So remember, this is not the only way to do this. So I'm going to say angle 7. Actually, I'm going to put it in a different order. I'm going to put angle 8 and angle 7 are supplementary. Now remember, linear pairs in there, a couple dies. Can you not draw on the desk, please? I am so sick of having to clean those off. That goes to everyone. I see marks on those, and I'm the one that has to clean that off. Don't write on the desks. Okay. So we have 4 is 7 are supplementary. We have 8 and 7 are supplementary. Remember, linear pairs on there a few times. Which linear pair one says they are supplementary? There's one that uses the word supplementary. There's one that uses the word 180. Yes. Not same. Remember, I'm talking about linear pair here. Because 7 and 8 are not same side interior. They're a linear pair. Which one says supplementary?
The theorem.
The theorem. The theorem. Linear pair theorem. I don't mean to pick on your answer, but no. I'm glad you said that. That's almost like a plant. Don't just all of a sudden say we only can use same side interior in all those. Supplementary angles still exist if they're linear pairs. So that's a good way to connect these. All right, now when I'm looking at this, we have 4 and 7 are supplementary, 8 and 7 are supplementary. This almost feels like the transitive property. It's not, but it's pretty close. I have 4 linking to 7, and I have 7 linking to 8 using supplementary angles. My step 3 is actually going to be angle 4 is congruent to angle 8. I'm going to call on you in a second because I think you know the answer. Why can I say that? I want you to think about that. Don't shout it out. Think about why, if I have 2 angles supplementary to the same angle, can I then say they're congruent? Because that's a big step to shorten this one. Patrick?
The congruent supplement there.
The congruent supplement theorem. Congruent supplement theorem. It's one of the most forgotten ones, but haven't we used that like almost every day lately? So it's probably one you should know because it shortens this proof a little bit. Is there anything wrong with using vertical angles and stuff? No. Let's look at the picture what I just did. I just showed that 8 and 4 are congruent. Can I now say that those lines are parallel? Yes, I can. And can someone raise your hand and say why I can say that J is parallel to K? Yeah. Corresponding angle converse. Thank you for saying the word. Converse. That's the important word there, is converse. Converse is that big important word. Yeah, go ahead.
So, is it the congruent supplement theorem because since 4 is congruent to 8, it can also replace that and then...
Yeah. I mean, honestly, that's one of the ways you can look at it. Because if I substitute either one of these, nothing should change, because 7 didn't change. But if you are supplementary to the same angle, you must have been congruent to begin with. It's a good one to know. I'd put a star by that if you didn't know that. That's a good one to use. Oh, hang on. Something important is happening. Okay, let's do our next one. Next one's a little shorter. We have A is parallel to B. Ooh, we have something already parallel. What does that open the door to if I already have parallel lines? All those theorems and postulates. So now I can say alternate interior angles are congruent. I can say same side interior angles are supplementary. So, Michael, I don't mean to pick on you, but this is where I got to start thinking about this stuff, that if I'm giving parallel lines, then I can use the theorems and postulates. If I need to prove, I have to use the converses. So if A is parallel to B, that is given. 2 is going to be, I could do the given again. You could put in the same step, or you could put it as a second step. I think I have enough room for this. This was also given. Now we should mark our information on here. So 2 is congruent to 3. All right, so I have 2 connected to 3. Those are already congruent. How do I somehow throw 1 into the mix? How do I throw 1 into this mix? We're done at 10:50. Think about it. Don't shout out any answers. Just think about it. We should be at the stage where we can see how 1 could be thrown into this mix. If you're not, we want to come and get help. This would be a real easy one on a test. Mason. Alternate interior angles. What are 1 and 2 other than alternate interior angles? So I'm looking at 1 and 2 being congruent because they are alternate interior angles. If I draw my lines, we should see that 1 and 2 are alternate interior angles. So that's my next move. I know they're parallel, so I can say those 2 things are congruent. My step 3 can be angle 2 is congruent to angle 1. That will be alternate interior angles.
Couldn't you also do it with angle 3 and 1? Because they're the same side interior?
No, we could not. We could not, because 3 isn't the entire same side interior angle. All right, now I have 3 to 2, 2 to 1, Is there something that links all of those together? What was that word? We're going to use the transitive property and we are done. I want you individually to look at this proof. If you could not do this, you are just copying the answer key. Because our homeworks had much more complicated proofs than this one. If you cannot do this one, you are just copying the answer key, and that means you need to come in and get help. Because there's going to be more proofs on this test, and they'll be weighted more. We're not going to grade them as friendly, because this is your second time seeing proofs. We've seen lots of proofs in this chapter. It's time for you to know whether you know the stuff or not. All right. Yeah, go ahead, John. It should be theorem, yeah. If I don't put anything on it, we can assume it's a theorem, but you can, because if I don't see the word converse, I assume you're using the theorem or the postulate. Okay. So yes, I'm going to box in theorem because we should be writing that in your notes. Yes?
So if we don't put the full, we just put alternate interior angles, we take off points.
I'm going to assume you meant theorem, but you should probably put theorem or postulate, particularly if it's a postulate. Otherwise, I'm going to assume you think it's a theorem. So if you put corresponding angle and you don't put postulate on there, I'm going to take off points for sure because I'm going to think you think it's a theorem. Okay. I wonder if I have enough space on this one. I'm just trying to figure out which one would be easier to do. Let's do... No, I don't want to do the homework. That's stupid. Let's do number 6. Let's do number 6 together so we can make sure we get that one done. Actually, not 6. Scratch that. Trying to find a good one we can use. Say that again? Put the completed notes on there. All right. Hey, let's do number 4 together. Let's do number 4 together. Number 4 together is another one where we have to... Look at number 4. 4 is weird. 4 is a really good one for us to get through. We start with supplementary angles. So we have angle 5 and angle 8 are supplementary. That's our given. Let's focus on that real quick. So that's my given. So let's look at 5 and 8 real quick. 5 is here. 8 is here. Now I need to prove 3 is congruent to 6. I'll highlight that in yellow. 3 and 6. So we know something about the pink stuff. We don't know stuff about the yellow ones yet. I need to prove 3 is congruent to... Oh, they're alternate interior angles. Aren't we done? Will, why not? We need the parallel lines first. We need parallel lines before I can say these two things are congruent. So we need to take these pink dots and prove that R is parallel to S first. Yes?
You say 8 and 6 are congruent?
Could we say 8 and 6 are congruent? We cannot, because do we have parallel lines yet? No, so we can't use those theorems or postulates. We first have to prove either alternate interior angles are congruent, which we don't know that yet. We need to prove that same side interior angles are supplementary, or we need to prove that corresponding angles are congruent. We have to do that first before we can just jump to saying that corresponding angles are congruent. Do you get what I'm saying? It's weird. That's why I'm showing this problem, because it's weird. Yeah?
So like in that case, could you say that 8 and 7 are linear pair?
We could say 8 and 7 are a linear pair. Yeah. And what does that mean about them?
That means 7 and 5 are corresponding.
That 5 and 7 would be corresponding? Yeah. We're getting there. We're getting there. But what does that mean about 8 and 7 if they're a linear pair? They're supplementary. So let's put that down first. So this is kind of like that first proof we have, that we're going to go from 8 to 7 by using the fact that they are a linear pair. And maybe you want to get in the, bless you, you might want to get in the habit of writing down what's important about what you're highlighting, because I can give you points for the proof up there. So we could do the same thing we did last time. We can say, you know what? Well, 8 and 7 will be supplementary. So angle 7 and angle 8 are also supplementary. And that's going to be, just for the sake of time, that'll be the linear pair theorem. If 5 is supplementary to 8 and 7 is supplementary to 8, what do we know an additional fact about that? Yeah.
5 is equal to 7.
5 is equal to 7. Yep. Angle 5. Yep. And you even did that. 5 is equal to 7. Whoop. 5 is congruent to 7. And that would be our congruent supplement theorem that I said we need to know. Since 5 is congruent to 7, what do we know about the two lines? If 5 and 7 are congruent, let me draw that on there. So we now have in red, 5 is congruent to 7. S has to be parallel to R. Can you follow that up since we don't have a bunch of time? Why do we know that?
Because angle 7 and 5 corresponding angles.
So it's corresponding angle. Postulate or converse that proves they're parallel? Converse or postulate that proves they're parallel? Converse. So if you're proving lines are parallel, you use the converse. Now we can put our parallel lines on there. And now we can say angle 3 is congruent to angle 6. Why? Yeah. Alternate interior angles. Would this be the converse or would this be the theorem? It would be the theorem because you are using the fact that they're parallel. So this would be the theorem. So be very, very careful on these. If you're proving the lines are parallel, you better be using the converse. If you're using the fact that they're parallel first, then you're using the theorem and postulates. But before you use the theorem and postulates, you better have parallel lines first. All right, guys, what I'll probably do is I will post